So yeah, hello everyone. My name is Siddharth. Along with Ram Goswami. We are the two of the moderator, and we are the part of a data science team at Analytical Vidya. And we'll be moderating this session for the whole time. So as I have already launched a one poll, please do attend that poll and participate in it. And for those who have joined this first time, uh, I'll just let them know why are we arranging these data session every day, because these sessions are really important to know about data science and data science domains. So basically data is a 1 hour 1 hour dedicated to the data, and it's a series webinar led by the top notch industry expert, where they teach and tell us about the data science knowledge. So as we know that we have a session model and guest estimation MLOps. So let me tell you about how this session will work and what is model guest estimation. So as already uh, Tosha has told you about that these are very essential goals for machine learning system to achieve. By analyzing these reports, you may determine whether or not the selected model is suitable for deployment or not. So it is, or if it is a only design use case or model that cannot be deployed or productionized before launching it to the cloud. So yeah, in this data session, as I have already told that Tushit will explain in details the process of model guesstimation and its need and its various applications in real life. So before starting this session, I would like to remind you few points. We are recording this sessions and we'll make the recording available in a few days on our YouTube channel, probably 2 or 3 days. Please use the Q&A question. Try to use Q&A section for asking any sort of questions. You might have you can ask it during the sessions also, and probably Toshit may answer these questions during the session or by the end of the session. It's up to him. So, and also we have already shared a feedback poll towards, we will share the feedback poll at the end of the session. And also it is really mandatory to participate in it. So yeah, now it's up to our speaker in this data session, Toshit. All the virtual stage is yours. Please hit it.
All right. Thank you, Siddharth. Thank you very much. Hello, everyone. And let me share you my screen. So what I'm planning to cover today, I already shared with you all, right? First 20-25 minutes, we will look into the slide and then we will jump into the code side. And first we'll understand the concept of the topic which I'm planning to share with you all. And then rest of the thing we will look into the code side. All right.
Sorry, Tushit, to interrupt. I'm really sorry.
Yeah.
I haven't introduced you to the attendees. I'm really sorry for that.
No problem.
Actually, okay. So, guys, let me tell you about Tushit. Tushit is currently working as a lead data scientist at HCL Technology, having 10 plus of years of experience in the field of artificial intelligence, product development, and research. He also worked in various reputed companies, including Emerson, Andres Plus, and Hauser, and Insoft, etc. So yeah, I guess we have very impactful keynote speaker, and he's also an author and a content creator also. So hope you will learn a lot from Tushit. So yes, now Tushit, you can continue at the 1 hour, and you have all yours.
Thank you, Siddharth. Thank you very much.
Yes.
Thank you
Okay.
for the nice introduction. All right. Anyway,
Okay.
I was about to share. All right, no problem. Okay, let me share you my screen, guys. Everyone. Okay, let me know when it is visible to everyone, and then we will start. All right. So I hope my screen is visible to everyone. Yes, no? Yeah, perfect. So it's visible. So let me, keep it here somewhere so that I can see what people are responding it here, right? So today we're going to talk about something called model guesstimation. So what you understand by looking into it, right? So guess the model which should be productionized, right? It is your model is production ready, right? That is the most important criteria which we are going to cover today. Okay. Yeah. So this is me. I am Tushit Dave, and I am a lead data scientist in SCL Technologies, associated with various product and research team. And I'm working on a lot of research given that the type of product what we are developing it here. And I handle the team inside my under me. There are a lot of people who are working with me along for the research side. And we do take care when whatever the launches and everything is going to happen in the future, given this like in SCL Technologies, right? So my first question to everyone, this is the everything you have in front of you. You have a model 1, you have a model 2, you have a model 3. You have got your accuracy of 90%, and your model is 93% confident for each prediction. Okay. There is another model 2 and model 3. By looking into these 3 particular models, can you tell me which model is performing better? Any guess? Any one of you? You can put it over the chat, and then we can have it. Maybe 3, model 3. A lot of people are saying 3. All right, 3, 3, 3, 3, 3, and so on and so forth. Perfect. 1. Okay. Okay. All right. All right. Thank you very much. So intuitively, I will say we can give a model 1 a priority. Oh, there's no relation with the precision and recall currently, my friend. So just hold on your breath. Okay. So I will say model 1, I will consider as a for the productionization point of view. Why? Because what it is saying, I am 90% confident that my model has given you the accuracy of 90% currently. But that model is saying I'm 93% confident whatever prediction I will give, it is going to be 93% confident. This is what I'm saying it here. Wherein in model 2 and model 3, see the difference what is coming up, right? Model 3 is saying I'm 92% accurate, but I'm 97% confident I will give you class label as a 0 or class label as a 1, right? The difference between these two is close to 3% here and 4% here, right? That is a challenge here, right? So you always have a 2 types of predictions. One prediction is a hard prediction, wherein you will say you predict the value of y, which is your target variable, which is nothing but your binary classes, and predict the value of x. Oh, sorry, given the data set x, right? Now, another thing is something called probabilistic prediction, wherein you take the probability of y and given the data set x, right? You will understand. You will understand, Aarti. Just give me some time. Yeah? You will understand it. Okay. Wherein y is a binary, class 1 or 0, maybe true or false, or fraud, non-fraud, or any of the other classes you take, right? So in this case, what happened when you apply the probabilistic prediction, it normally gives you the ranking. So you need to rank the model. That is being called as a ranking prediction, and then you pass that ranking prediction into the hard prediction. That is the flow normally you take when you proceed for the probabilistic estimates, right? When I say this, the most important criteria what we need to cover it up here is take the probabilistic prediction, right? I'm saying the probabilistic prediction is going to be, I am 93% confident for each observation, or each observation is going to be 93% correct for the 93%. That is what I meant for here. Given the accuracy of the model 90%, I am for each data point or each observation, It is saying in unseen data, I am 93% confident you will get a class level 0 or 1. That is what it meant for here. All right. So let's move further. Imagine you have a age, you have an education, you have a total experience and occupation. You fed into a model of random forest. Imagine you have chosen the random forest as a model, right? Now what you will do, you will basically calculate the probabilistic estimate here, right? This is your predictive probability, right? So definitely these are some of them are categorical features, as you might have noticed. Then what we will do, given this categorical feature, right, we will convert it to the numeric, and we got a probabilistic value which is 0.2, right? So what I'm saying it here, when I got this, I'm saying I am 20, your model is saying I am 20% confident people will get the given this information, given this age, education, total experience, occupation, you will achieve the salary of maybe more than 50%, sorry, more than $50,000 or less than $50,000, right? I just took an example of census income. You might have heard of this particular data set. It's a very popular data set. So I just took that particular example and kept it here for your easy reference, right? So let's move further. So this is the intuition basically you will achieve out of it. I am saying 20% who obtain the y hat or p hat, which is the probability you have got as a 0.2, are likely to receive salary more than $50,000 given the features you fed into the model. That is what the intuition you will take out of it, right? Now, if you look into this page, so we will try to understand the overall scenario, how this has been applied and why this is important, why it is not, it is very, people don't cover it. But let me tell you, it needs to be covered in a proper way. So your first pointer is high risk use cases, right? Now, why I'm saying high risk use cases, right? Imagine, let's take an example of maybe healthcare sector, okay, which is like highly critical sector we can consider, right? Imagine patient is suffering from the specific disease, right? Hence doctor definitely needs to give some specific medicine to the patient, yes or no, right? It is definitely required. And imagine whatever the features that doctor has suggested to you as a data scientist has given you some of the important features. You give me the accuracy of the model, right? You got the accuracy of 90%, right? But herein we also need to talk about the confidence of the model, like how much confidence your model has. So whatever the prediction you have got, how correct it is, right? This is where the health sector problem comes into the picture, because definitely either you will say you give given the disease, you suggest this particular medicine, or you suggest whether the guy is having a heart disease or not. But your model has to be very good, in terms of probability. I am 90% confident this person is definitely has a heart disease. Accuracy and probabilistic estimation both are very different. That's the reason I clearly mentioned it here. Calibration or probability estimation is not at all equivalent to accuracy. There is no correlation between them, right? Now, if I say, given this information, given, for example, you have run close to 5 models or 6 models, because you have no idea in real world use cases what kind of model basically will work. So there are multiple type of model. There is a AdaBoost, there is a random forest, there is a logistic regression, or bunch of classification models are here, right? So imagine in this way, imagine you have ran like close to 7 models. You applied all the grids. Some model gave you 90% accuracy, some model gave you 89% accuracy. Everything is looking pretty good to you, like given or you consider as a prisoner recall wherever the false positive, false negative. Someone was telling me about some imbalance thing and all, right? Imbalance data set or XYZ. But even though you did everything here, right, still imagine you have got an accuracy of 90% for each model. Every model you might have looked into your present recall, or you wanted to take care of your false positives as well. You have taken care of everything, but still, are you confident out of this one of 7 models, which model will give me best possible result? No one can say this, or any one of you can tell me. Then it's pretty good, because you are like going to be a should be a lead data scientist, or maybe a the head of the data science department in the Google, right? But overall, the picture, my basic point here is, we need to figure it out, the best optimized model given the data set. Okay, now that the method which I'm trying to propose you, or the method which I'm trying to share with you all, will contain you have an option to improve your models as well, right? So what are the mistakes you will have to achieve the high probability value? So there are 2 labels in your, one is positive label and one is negative label, right? So for the positive label or true label, what is the probabilistic score you have, or whether you should consider it in a given the important features which has been mentioned in your data set, you are achieving a good probabilistic value or good probabilistic result based on that data point, right? So this is what the important comes in, important aspects comes here, right? Now on the right hand side, if you see okay, so before I jump onto the right hand side, which the picture which has been in 3-dimensional space, right? I will not go there. So let's understand, the calibration or probability estimate is not at all equivalent to accuracy, right? Well calibrated model can also have a low accuracy. Why? Imagine you have worked on a one data set where you have, which is highly balanced data set. Okay, it is not at all imbalanced. Highly balanced, that is 50-50%. You can consider as a iris data set, right? 50-50% data set, right? 50-50% data points you have it. So are we saying that given this 50%, you have got accuracy of your model is 95%, given the data set is highly balanced now? That is to say, whatever the sample data point you will achieve, or sample information you will achieve in your from your population in the future, right? You are 95% confident this should fall under the iris, or it should fall under the versicolor or virginica, right? But here I'm saying it is not at all possible. It is going to happen. There is a 50% probability will be applied into it for the given model, whatever model you choose, right? So even though if you have a low accuracy of your model, so if now imagine you have an imbalanced data set, right? When we talk about where you might have applied a smooth technique or oversampling or undersampling, all this technique you might have applied here. Imagine you applied imbalanced data set for the one class, right? You will always achieve an accuracy of 95%. So what you will do? You will try to do oversampling for the negative class and try to bring to the same level. But here still you will get this particular problem here. You will definitely may achieve accuracy of your model 90%, but your model is not confident given the data point they will achieve the confidence score of 95%. That is the biggest challenge here. Okay, so there are 2 terms. Model can have a high accuracy and can have a bad probabilistic estimated values, right? Now, when we talk about your all the action depends upon the precise probability. What do I mean with it? Imagine you're working for one company for the issuance of the loan. They wanted to issue the loan, right? And they say, you as a data scientist, can you tell me if I will provide the loan to this guy, whether he or she will be able to repay me that loan or not, right? This is where the precise probability or that particular probability estimated value comes into the picture, because your model may have a good score altogether, 90%, 95%, but it is not confident enough to provide you that information which your organization is looking for, where you can save the money for your own organization, right? So this is where the probabilistic estimate comes into the picture. Okay, this is where the calibration comes into the picture. So probabilistic estimate is not alone work alone. There is a calibration is required for everywhere, right? Now I'm saying, I'm talking about the model quality. I want to assess my model quality here. Okay, so I'm saying it here. I am 80 or 90% confident my model will provide me the correct result. So you as a data scientist needs to have a clear-cut information whether your generated model or developed model, when it will be deployed, given the data set, is confident enough to give you good and accurate result, right? So this is where again this particular method comes in. Okay, now here the next thing is model impactness, or maybe you can call this as a simulation, right? So in this case, let me take you an example here. I think that will be better. So imagine you're working for one company, like automobile company, and they are saying, given the model, how much money I can save. Given the model, how much money I can save. Or maybe you're working for one power company, one power industry, wherein bunch of steam is being flowing into the boilers and turbines uh, and generating electricity. So that company is asking you, okay, can you tell me what is the impactness of your model? You have it, right? How much given the model, how much money we can save, whatever the model you have deployed there. So this is where the impactness of the model comes into the picture by using the calibration or by using the probabilistic estimate. And you're already all are aware nowadays, in fairness and biasness is the most important criteria. How fair your model is, how much data points are biased towards your model. When you notice in terms of imbalanced data set, because your data set is biased towards one class, right? So this is again very important implications which factor which we should consider it, okay, when we talk about calibration. Now the next point here is recalibrating for the model drift. Now the model drift normally comes into the picture when we applied any model. Maybe imagine you applied random forest as a model, right? Or you might have applied naive Bayes as a model, right? Now you might have noticed you fed your data point into this model after doing all the pre-processing, all the feature transformation and everything, right? Now somehow what happened, the COVID came in, right? Now when the COVID came in, what is the problem will come? either there is going to be a very this problem is going to happen. What you will say, problem pertaining to your is it I'm not audible, guys? Because people are saying is a poor communication, something is happening. Hello?
Okay, from my side, your voice is quite clear. Maybe some of the...
Okay. All right. So, okay. So here is the calibration what I'm talking about, right? So imagine there is a probabilistic value which is between 0 and 1, and this is your calibrated line which you can see here. This is your calibrated line, right? This particular calibrated line always been a diagonal. There is no changes is going to happen in terms of this, right? So this is your ideal line which you can consider currently 0 to 1. Now I am saying that I am 80% confident enough that whatever the result I have is going to be confident. My model is saying this. So when we talk about this particular criteria, this is how the entire things works, right? You take the data point, you take your unseen data point, and you score the specific value out of it. So that's how the entire data points will come into the picture, and each for the unseen data specifically. When I'm talking about the unseen data, I'm not talking about the test data or maybe trained data. You leave it behind. There's no correlation between them, right? Now, so if you notice here, I have a data point probabilistic value, as you can see here, this blue line. So I've ran one of the naive-based model in one of the use cases, and you can see for the 0.6 probabilistic value which has been mentioned here, right? And I'm saying when you got your 0.6 probabilistic value here, what is the score on the y-axis? The fraction of positive. It is just close to 0.1, right? So you are saying for the 0.1, the binning score what you are taking out of the given data point is very low. You are not at all confident enough. Your model is not at all confident enough to provide you the accurate result. So this is being called a reliability curve. This is being called a reliability curve. And when we talk about the reliability curve, there has always been binning on the probabilistic value which is being developed and plotted on your between in two-dimensional space, right? So if we achieve this particular data, this blue line which has been noticed here, if you drop it, right? If you increase the let length from calibrate from 0 to 1, you can keep it here. That is going to be a most probable best model which you can consider for your use case, given the model, given the data set. And this is what we need to achieve. We need to bring our product, this probabilistic model line near to this calibrated line, near to this diagonal line. That's how the entire calibration works. All right. So this is just a small intuition, guys. There is no such thing here. You might have noticed there is a lot of formulas and all everything here. So reliability, I'm just explaining my reliability curve here. You take the group of predictions into the bins, as I said earlier in my previous slide. Okay. And the fraction of positive per win. Right? You take the binning, you take the probabilistic value, you bin it, and you keep it here in two-dimensional space. Then you develop a confidence on it. And when you develop a confidence on it, you will say, my model is 90% confident, 95% confident enough to show you the result, to give you the proper result out of it. Right? So this is the most important aspect we need to consider when we talk about the machine learning operation side. So because what happened in real world, data normally ingested in continuous basis. So there might be a threshold values which has been defined. There might be a bunch of data point like 20,000 or maybe 1 lakh data point is floating into your model, right? Into your pipeline, given the model in your pipeline, right? So what happened? You need to have a proper prediction and proper probabilistic value, because this is where the revenue has been involved for any other organization. So we need to consider this particular criteria when we talk about any kind of reliability curve and when we talk about the calibration. All right. So what I'm going to do here, this is my trained data set. You take your features and you're feeding into the random forest, right? Then you take your, so make a note, this trained data set won't be used further. Okay. Now what you're going to do, you take the test data set, you check the label what you're looking for, label 1 or label 0, whatever the positive label you have, you predict the probabilistic value and then feed into the logistic regression model as one of the calibration model I'm considering currently. Okay. Then you test this particular logistic regression or calibrated model from the validation set and then check the value, how it is being performed between your test result and the validated result. And then you prepare, you will say, I am this particular calibrated model will work better compared to your other models which has been notified or which you already developed in your given the from your use case. All right. So this is the just a small this thing plot which has been developed in my use case. Okay. So you have an original one. As you can see, the original one is the blue line, right? And you might have noticed, you can notice here, it is like going away from your calibrated line, right? This diagonal is your calibrated line, or maybe you can consider this as ideal line. All right. Now, this orange data point, which you have developed, is real close to this ideal line now. Now you can say, okay, this is working pretty fine now. It is working, my calibrated model is working better compared to my prediction line, compared to my previous model, right? So just a moment. So what I'm going to do here is I'm just I've developed a this particular use case. I just bought this particular data point here, this data set here, which is nothing but a census data set, right? So you have an age, you have a work class, you have an education, you have a marital status, and what you want to predict here, given this information, whether the person will achieve the salary more than $50,000 or less than $50,000, right? This is what you want to predict here, right? So this is just a small pre-processing. I have applied it here, and now I've run my models. So as you can see here, when I ran my models, just for the after the small pre-processing, right, you have got accuracy of 85%. On the test data set, it is 83%. For random forest classifiers also you have it, and ADA boost classifier also you have it, right? But by looking into this, by looking into these models, we cannot say which model will work best in terms of predictions, in terms of probabilistic scores, because it is saying I have got a pretty good accuracy, 85%. I have got a on test data set, it is good. It is also pretty good results, as you can see here. All the models having a very good results given the data set. Now,
Tushit, are you sharing a new slides? Because people cannot see the new one.
oh, okay.
They are still in the PPT.
Okay, just a moment. Is it visible to everyone?
Not yet. Yeah, now it's visible.
Okay, so let me restart it, right?
Yeah, you can just go through it.
Yeah. So this is the data set which I bought it from the GitHub. Given this information, given this label, given these features, right, I want to predict whether the salary of the person is going to be less than $50,000 or more than $50,000. This census income data set, I hope everybody is aware of, right? And just this is just a small pre-processing. I've done it here, so you can look into it later and then splitting into the training test for now, and ran my model. Okay, and this is the accuracy what you have got here currently, as you can see here, right? So all the models perform pretty good, nothing wrong in it, right? But now Nothing wrong in it, right? So now what I'm trying to do here is I want to develop a calibrated result for the random forest model. This is my random forest model, which I've chosen, right? Now have a look what is happening here. It is very much close to your calibrated line, or maybe you can consider as the ideal line, which is supposed to be. There's a diagonal line what you have. So you basically calculate the Brier score here, something called Brier score, right? Brier score, lower the Brier score, better the model, right? We will look in upcoming thing what is going to happen. I will tell you. Now what I'm trying to do here is the same data set I'm converting into the splitting into three ways: train, test, and validation. Okay, as you can see here, everywhere I have a 10,000, close to 10,000 data point, wherein in your validation is wrongly written. Please ignore it. It's supposed to be validation. Okay, it's supposed to be validation. So it should be, it is 11,000 data points, sir. Currently you have it. Now, this is very important stuff, which I'm showing it here currently. The difference between your trained dataset model feeding and test dataset model feeding. So there's a drift, as you can see here currently, which is happening. The drift between train and test. If you notice here, the test drift is skewed in this case everywhere, right? So when we talk about this test drift and when we compare this thing with the validation drift, if you have figured it out, there is a skewness is coming in each and every data point, or each and every data you are feeding into it. So either what you will do, either you will retrain your model, okay, do all the pre-processing, all the feature transformation again, and then you refeed into the model and get the predictions. You can do that. This is what you can do, right? But it is just information. I just wanted to check the difference between these two. So I just mentioned it here just for the information. I have shared that another thought with you. Now, what I'm going to do here, what I'm trying to do here is, as you can see, I have developed this my ideal line, and each model. So I've applied three models here: random forest, the support vector classifier, and naive Bayes. All right. So if you look into it, this is the ideal line, the probabilistic value into the binning format. You have it here, right? Which is very close to your ideal line currently. But when you look into your SVC line, it is quite far. The trend is very different compared to your random forest, right? The same is applicable to naive Bayes as well. So naive Bayes is very poor performant, even though you might have a accuracy of your model 95% or 90%, but it is performing very poor, right? So if we look deeply, all the three lines, all the three this blue line or probabilistic estimated line, I can say that, okay, my random forest is performing better. But is it really performing better? We yet to check this. How we can check? We will calibrate it. We will create our own model, calibrated model, and check with this particular random forest model. All right. Now have a look. So this is I am doing. I have created one calibrated model for myself, which is nothing but my LR model, logistic regression model. Okay, and I checked it with this. Right. I still say the random forest is performing better, but compared to others, my calibrated model is performing better compared to SVC or naive Bayes. Right, that is the intuition. Basically, we will take it out from this given information, from these plots, right? So if you look closely, so later on I'm also testing it, how this particular information is basically useful for you, right? Just give me a moment. I will explain that part as well. Now, if you look into it closely, your random forest is very close to your ideal line, even though your calibrated trend is is poor compared to random forest now, right? Now, let's move further, right? Now, let me keep it here as a random forest. Let me keep it as a random forest here. Okay. And now let's do the run. And we will check uncalibrated values, probabilistic values, and calibrated probabilistic values. So have you noticed the calibrated probabilistic values is good for random forest, wherein the uncalibrated probabilistic values, yeah. However, if we talk about the uncalibrated probabilistic values, which is poor, that is to say, we can say that we should consider random forest as a better model which should be deployed for the prediction point of view in real world use cases. However, if you check with NB, naive Bayes, let's check what is happening in case of NB. Can you check what is happening? The uncalibrated is 0.0 and calibrated is 0.02. That is to say, the naive Bayes is really performing very poor. It cannot be deployed. So if you notice here, these are the major information which we should capture when we talk about deployment of the model. So wherever the probabilities are there, wherever the probabilities or wherever the classification is there, so definitely the probability is going to be part of it, and it should be considered. This probabilistic values or calibration should be considered before deploying any of the models, right? Now, this is a very important aspect which we should consider when we talk about the model drifting or any kind of drifting, right? The model drifting is a very important role because it will tell you whether you should go for the, you should train your model or you should stay back, right? So if you find out, if you figure it out in your unseen data set, if you figure it out that there is a distribution, in this distribution there's drifting is happening, right? So in that case, either you will go and retrain the model or you will stay back. So this is a very important criteria which we should cover when the model is being deployed in the production. All right. So this is the end of the topic which I wanted to cover with cover with you. If you have any doubt, please do ask the questions. I'm happy to answer those.
Tushit,
Yes.
Just a small reminder to them. Actually, guys, I have launched a feedback poll. Please do participate in it. And yeah, you can ask your question and Tushit will try to answer each and every one. So yeah, Tushit, go ahead.
Yes, A to B testing calibration will differ, definitely. Calibration is something that you want to see which model is best for your data set, right? So that is how it will differ. How do we monitor it with object detection kind of use cases? Okay. So in case of object detection, what happened? Yeah, in case of object detection, what happened? You can consider there are multiple classes are there, right? So with one, for example, let me take one of the use case. For example, there is a toll, okay, and from that toll there are a bunch of vehicle are passing, and you want to detect whether this particular toll, passed out vehicles from that particular toll is a truck or car or bike or something, right? So in that case, what will happen? You take the multi-class detection there. So you calibrate, first you develop your model, any of the model, whatever you have chosen, okay, and then you recalibrate it by using the same method which I have applied it, and then you can say, okay, please, this particular line or probabilistic values are this currently, and you can get this particular confidence level, and you simple. So the method for the tabular and object detection will work in the same way. No such differences will come. How do we interpret calibration curve? I mean, when line is above ideal or below ideal line. Okay. So line is above ideal or below line. What happened? If it is moving in the same trend, if it is moving into the same trend, we can say that it is very much close to it, your calibration line. If the calibration line is very close to your ideal line and it is moving towards in the same direction, you can say that, okay, this calibrated model is pretty good, performing good compared to other models. The same is applicable with the other models. So normally we say, okay, this particular data point should fall between 0 and 1. This probabilistic value should fall between 0 and 1 for sure. So is there a package for the calibration and model evaluation as you presented? No, there is no such packages are there. There is one library is there, but it is in GitHub, but it is not yet fully developed. It's in beta stage currently. So we need to write our own code as I've showed here currently, right? So you need to develop your own probabilistic value. Likewise this. Can you automate calibration checks to detect data drift, or you manually check periodically? Okay. So calibration check normally happen when you are at the development stage, right? And wherein the data drift normally takes place when your model is being deployed. So this is a story of before feeding into the before you feeding your model into the productionization stage. It's before that, right? Yeah. Any other question, guys?
Tushit, we have some question in the Q&A panel. Can you answer them, because we have few of them there?
Okay. Yeah, sure, Ankit. Definitely. Can we use the weight of evidence for model calibration? Okay. So I would like to understand when we talk about the weight of evidence for the model calibration. So what is the evidence you will consider it here? The probabilistic values you will consider as evidence, right? So when we talk about any kind of probabilistic value which you want to calibrate, those are basically you can consider as a weight for the given use case. But in the end, you need to define how much your model is performing on the unseen data, how good your model is performing on the unseen data. That is a most important thing what we need to consider when we talk about the weight of evidence for the model calibration. Why we need calibration? To figure it out the best model, or you can consider which model has been performed better, and how good it is for the on the given probabilistic values, how good it is, and it is meeting your ideal line or not. That's the reason you need a calibration. how we can detect the drift. The difference between mean and mean of your train and test will detect the drift. Okay, so if you have a, so let me share you here, I think, just a moment. So as you can see here, right, the difference of your train dataset and test dataset, if you will take out the mean of this train and test, if they are very close to each other, you can say, okay, this is performing better. If it is far, you will say there is a drift is happening in your train and test. No, this is not applicable in case of regression, guys, because wherever the probabilistic value you can define only in case of classification problems. It is not applicable in terms of regression. Okay, how do you decide which model to use as a reference model? I am not deciding it. It has been defined based on this particular probabilistic value, and these plots, if it is very close to your model trend is very close to your ideal line, you can say this particular model can be used for the deployment or for the productionization. You can apply any of the models. It could be n number of models. It could be naive Bayes. It could be random forest. It could be anything. Yes, Gaussian naive Bayes. You're right. Yes, when you have identified your model is performing best and it is very close to your ideal trend, then you can go for the deployment, because you have already figured it out. Given the 7 models, given the 5 models, this particular model is performing best out of those 7 models. Can you automate calibration checks to detect data drift or manually check periodically? Okay, so make a note, the data drift and calibration both are different. Okay, data drift is like completely based on your train and test raw data set, or maybe that data set you should consider which you're feeding into the model, or which that data point you're feeding into the models, right? This is where you will check your data drift. So there is a you already created a pipeline and you already done everything, and now your numerical values are ready to feed into the model. This is where you check your data drift, because when you feed into the model, and you will see for each data point how your model is performing, given the Shapley value. If when we talk about the Shapley value, you calculate the Shapley value and you see the performance of your model for each data point, right? Also, you can check there itself for when your data points are coming into the batch format, like in 20 minutes or 15 minutes, there are 50,000 or 20,000, 90,000 data points are coming up. How that distribution look like for your test data set, and how it is comparable with the unseen data set when we talk about it is moving into the batches from data ingestion point of view. Calibration is validation for the model, Lokesh. How do you estimate the calibration and take a decision before deployment? Okay. So as I said earlier, if your model is very close to this ideal line, you will consider this as a best model. So in below, if you notice here, your calibration line is poor compared to random forest currently, right? So if you put random forest here, and I have generated few random data points for myself, as you notice here, right, and converted everything into the numpy array and checked it, so it will generate a value between 0 and 1, first thing. And now you can see here your uncalibrated random forest model probabilistic is 58. However, In case of calibration, it is 50. So that is to say, we can say that, okay, my random forest model is performing better compared to my calibrated model, which is nothing but a linear regression model. Oh, sorry, logistic regression model, right? So that's how you can you can easily look into it and figure it out. How I can improvise the calibration to reach the ideal line. How I can improvise the calibration to reach the ideal line. What does it mean? Actually, I did not get the question. Can you reframe it, Salima? Because this question is not clear to me.
Tushit, some of the attendees are want you to like share this notebook. If is it possible for you?
Yeah, please, I will do that. I will share
Sure.
with you, and then you can, yeah.
You can directly send the link in the chat box.
Yeah. All right.
Uh,
So just a moment. Yeah, is there? Okay. Is there any other question I can help you with? Yeah. So you might be thinking there is a very important, this someone has said, right, about the ROC curve. So ROC and calibration both are very different, right? It is absolutely correct what Sumant is saying. Why? Because ROC curve will definitely give you line between 0 and 1, but there is a threshold value which you define, right? But calibration, by looking into the ROC between the TPR and FPR, you cannot say the area, the highest area and under the curve model is the best model for you. You cannot just blindly say this. Your focus is going to be like this. You want to figure it out. Your model, the model what you have chosen, is giving you how confident that particular model is, and whether it is able to achieve the 90% accuracy or 80% accuracy or not for each data point. That is what you're looking for. So your model has to be very confident enough. You are confident, but is it your model is confident? This is the question. So we, as a data scientist, need to look into it pretty closely. All right. Is there any other question I can help you with, guys? Or please do ask. I'm happy to answer those. So always make a note, whenever in your real world scenario, whenever you encounter with bad data set, or because data set in real world normally very skewed. Okay. So, and you are performing a kind of classification problem in your data set. Try to apply and figure it out your best possible model, right? And this is how you can figure out your best possible model. You take any of the use cases. It doesn't matter that use cases belong to accuracy or precision or recall or anything. You can choose that best precision wala model, but there is accuracy still are there, right? By taking that information, you calibrate, start comparing with other models, create a calibrated model for yourself, compare with this ideal line, ideal dotted line, and see how your model is giving you the result. And that model only I would suggest to deploy. Never go for it. It is very much possible you might need to deploy your calibrated model as well. It all depends. Process of calibration to reach the ideal line, I meant. Is there any standard way? There is no standard way, Salima. It is a comparison of the model. It is a comparison of the model, your calibrated model, as well as the other 7 models, right? It is a comparison of all the models, how it is close to your ideal line, as you can see in the plot, how it is close to your ideal line. Yeah, Bijoy has already shared on the chat. I think everybody is having it.
Actually, that link is working, but that link is requiring access.
Okay.
So maybe you need to give them the access.
Let me open it for all. Just a moment.
Yeah. Guys, I'm attaching the link again. Do copy it, and Tushit is making it public.
Yeah, it is public now. Please do use it for your purpose. All right. So Siddharth, are we done, or is there anything else? Yeah.
I guess we have answered most of the questions, right? So yeah, I guess we are good enough. So okay, thanks a lot, Tushit, on the behalf of Analytical Vidya. So I would like to thank you for devoting your time and delivering such a great session. I'm sure it was really insightful and really comprehensive and appropriate for a lot of expertise or students. So hopefully we can conduct more sessions with you in the future. And thank you, Tushit. And I would like to request the attendees to please participate in the feedback poll, as it helps us to conduct more such sessions. If you face any kind of difficulties, please connect with us at editor@analyticsvidya.com. And so tomorrow we have another session at the same time, 7 p.m. IST, which is on getting started with AWS EC2. Some another speaker will be there, obviously a top-notch speaker. So as I said, recording of the session will be available after 2 or 3 days on our YouTube channel. Do check our YouTube channel, Analytical Vidya. You can find a very good data session which are been recorded before. So yes, I guess we are on our end. And thank you guys for attending the session, and thank you Tushit once again for delivering such a great and knowledgeable session. Thank you, Tushit.
Thank you very much. Yep.
So okay guys, now I'm closing this webinar, and hope you have a great day and have a good night. Goodbye. Thank you. See you tomorrow. Okay, so some of the links are being posted in the chat box with about the YouTube channel, about the data session which will be delivered tomorrow. Please do join, please do register, and I hope this 1 hour session will help you a lot and progress in your career. Thank you guys for attending.